Couple quick examples for two-step equations. As I look at this problem, I want to get the variable by itself. The easiest thing to move would be this constant here. And so my first step is to say 3y, I'm going to migrate the 2 over, equals 8 was originally on the right-hand side, so it stays there. And the migrating term is always written second. And so it migrates over, it's negative 2 on the left, so to the right it would be positive 2. I like this method because you see that I have 3 terms here, I still have 3 terms here. All I've done was migrate a term, so I neither create nor lose any terms. And then of course when I simplify this, I could write this as 3y equaling 10. And the last step would be to divide by 3. As you divide by 3, we can say y would equal 3 goes into 10 3 times, leaves 1 left over, and you always have that divisor in your fraction unless it happens to reduce. And so this becomes 3 1/3. A second example, maybe I'll say something like 4 minus 7m equals 19. I want to have my variables positive, so I'm not afraid to have a couple migrating terms. When I look at this, I see that it's negative 7m. I will move it over to the right, and I'll force that 19 over to the left. The condition is that you always write the original terms first. The 4 hasn't moved, so I'm going to write it first. I see that the 19 moves over to the left. Since it was positive here, it comes over as a negative 19. The negative 7m moves over to the right. Since it's negative here, it goes over as a positive 7m. I can simplify those constants. 4 take away 19 would be negative 15. And the last step would be to divide both sides by the coefficient of 7. As you divide by that number in front of the variable, you see that 7 goes into negative 15 negative 2 times, with 1 left over, so I call it 1. I retain that divisor, so I call it negative 2 1/7 equals m. One of the cautions I want to throw out to everybody is be careful. If you move that variable to the right-hand side, then solve it on the right-hand side. Don't do all your work here and then in the last step switch it around. There is no law that says that the variable has to be on the left-hand side. It can be solved on the right-hand side and it's equally correct. In fact, in later chapters, that's going to cause us an issue if we're swapping these right and left. Just leave them the way they are. You solve for the variable, it's positive, those are all of our rules, and we have no control over what happens for your answer. Let's look at another example before we move on. Maybe we'll have something like this. It'll say negative 3 is equal to x over 2 plus 5. When I see fractions, my first step is always to remove those fractions. So I multiply by a common denominator. In this case, the common denominator in the problem is 2. So I multiply by 2, and I distribute to each and every term. If I distribute here, this becomes negative 6. 2 times x over 2. Now remember, this 2 is a numerator, this is denominator. You can let those cancel out. And that was the whole idea by multiplying by the common denominator. And that leaves us with x. And 2 times 5 would be 10. Now you want to get the variable by itself and positive. Currently it's by itself, or positive rather, and the 10 is the only thing in the way, so we can easily move that by migrating it. And so we rewrite this as negative 7, negative 6, the original term, and the migrating term, negative 10. Remember, it's got a change that goes across the equal sign, equals x. So if you owe me 6 and you owe me 10, you owe me 16. I'll do one more of those. This time we'll say something like 11 minus 2/3 x equals 4. Looking at this problem, I see a fraction. I'm going to get rid of my fractions. I always get rid of those fractions. Multiply by the common denominator. In this case, that's 3. And I distribute. So 3 times 11 is 33. 3 times negative 2/3. I let the 3's cancel out. That means I'd be left with negative 2x. And 3 times 4 is 12. Now I want to get the variable by itself and positive. I'm not afraid to move my variable, so I'm going to move that variable over, meaning that the right-hand side will be reserved for variables. This 12 would be in the way, so I'll move it to the left. And so we can call this 33, original term, minus 12, migrating term, equals 2x. Now 33 take away 12 is 21. I divide by 2, and we can say x is equal to 10 and 1/2. Again, when you migrate a term, it's particularly your variable, and it ends up on the right-hand side, leave it there. Solve it that way. There's nothing wrong with saying 10 and 1/2 is equal to x.